Hello, folks, and welcome to Chapter 2. Today we're going to be talking about relations and functions. Now, I will warn you in advance, some of this stuff is likely going to be review for some of you, and the problem is that there is some stuff that is new. So I am going to ask you guys to, if you need to skip through it, that's fine, but make sure that you pay attention as we get into the function notation stuff. Okay, uh, we're going to be talking about presentations and how you can display data in a variety of ways. Okay, domain and range of a relation, whether a relation is a function, evaluating functions, and modeling real-life situations with a function rule. I need to tell you right now that this, evaluating a function, is the one that I would emphasize. This is one that's going to carry over for a couple of years, and you have to make sure that you're comfortable doing it. Modeling real-world situations with a function rule is not terribly exciting, and I don't think anybody's going to be terribly surprised that you have some math Excel to mess with tonight. So anyway, back into this. First up, relations and functions. Here are some definitions that I would encourage you to copy down. Unless you've printed out a copy of notes. So a relation is just a set of ordered pairs. That's it. Really doesn't matter what set of ordered pairs, just ordered pairs. We talk about the domain being all of the first components, the x value, and the range is a set of all the y components. For those people that struggle with, well, wait a second, how am I supposed to keep this straight? Notice that D comes before R, just like X comes before Y. So when in doubt, go back to alphabetical order. Last thing I need to talk about is the concept of a function. Now, a function is a relation which follows a specific set of rules. It's one in which each element of the domain corresponds with exactly one element in the range. Now, I've heard this described so many different ways that for every x, there is exactly one y. You can't have more than one y. But the thing I want to emphasize on this is it's going to kind of be common sense because the term function is something that's in the common language. If you've got a family relationship that is functional, okay, it follows a certain set of rules. If you have a dysfunctional relationship, you're going to say, no, it doesn't follow the rules that you're supposed to follow. Anybody can be a relation, including your crazy uncle. But to be in a functional relationship, you have to follow a certain set of rules. And my rule is that for every x that you see, there will only be one y. You cannot have an x coordinate with two y coordinates. Now, I will also talk about, they really do, for some reason, like to emphasize these four ways of representing relations. I will be honest with you, I tend to emphasize only three of them because those are the three that I generally tend to see. You write them as an ordered pair, x and y. You can put them in a table of values, and that's all cool. And you can also graph them. But I want to emphasize that there is something out there called a mapping diagram. It's something that's kind of not as much in vogue, but it can be used. And so in this way, I would probably emphasize to you that the mapping diagram is kind of nice for being able to say, hey, let's take a look right here because that x is going to two different y's and it jumps out at you a little bit more. But again, from my experience, the mapping diagram is going to be least frequently used. So anyway, back into this. So let's take an example. Okay, average water temperature in the Gulf of Mexico off of Key West, Florida, varies in terms of temperatures. In January, the average temperature is 68. In February, it's 70. In March, it's 75. And in April, it's 78 degrees. So let's take a look and see how we can represent that. Well, how can we represent that four different ways? Well, we could write it as ordered pairs, with the x-coordinate being the month and the y-coordinate being the temperature. So I'm going to do that and say, hey, whoops, let's do it this way. Okay, and I can do it something like that there. Not too exciting. I can also do it using that mapping technique, which, again, not terribly exciting. A table of values, you can see that in a chart with x and y. And then we can also talk about how Sorry, just going around there. And say that we can also do it as a graph in general, just an x and y coordinate. Okay. Just want to emphasize that for people not familiar, this little squiggle symbol means that you've jumped up by something other than the normal interval. You can see that the rest of the y coordinate is going up by 4s. Well, in this case, they didn't necessarily follow that, so just be aware. All right, anyway, and that does happen sometimes in charts and graphs. Okay, so given the situation here, what would my domain be? Well, I'm truly hoping that people are just instantly saying, well, that's really not hard. It's going to be 1, 2, 3, 4. Okay, should be easy to do, easy to come up with. Well, how about if I ask you to find the range? Once again, I am truly hoping that people are able to very quickly say that's going to be 68, 70, 75, and 78. Now, as a general rule, you're going to find that often we're going to put things in order when we are listing domain and range. Okay, anyway, back to the next stuff in terms of more examples. Again, the function is a relation in which each element of the domain corresponds with exactly one element of the range. So please be careful and emphasize that. So we'll take a look. X values can't repeat. Is this function, or is this relation a function? And I'm going to look and I'm going to say, okay, I've got 4, -1, 8, 6, 1, -1, 6, 6, and 4, 1. And I'm truly hoping that many people are right now saying, yeah, I've got 4 here and I've got 4 there, and they're 2 different y coordinates. Because I'm seeing 4 with different y coordinates, no, that doesn't work. How about if we do it using the mapping? Okay, yeah, each one of the x's goes to a particular y. Cool. And you notice, once again, even in the mapping, they're going to go in order. So that works out. Let's take a look at this one here. And you're looking and you're saying, well, I only see every coordinate appearing once. So I'm going to say, yeah, domain values are exactly one value. Now, I might have 1 or 2 people commenting, wait a second, I see 14 here and I see 14 there. Doesn't that break the rule? No, because remember, it's the x values that can't repeat. The y values, it's fine if they repeat. All right, and let's just jump on then and determine if the following situation represents a function. Okay, so for the x, do you get more than one y? A person's height to their age. Well, you can talk about not necessarily, because it doesn't matter what your age is. Some people remain the same height once you get to a certain age. So you're not going to have that sort of relationship going on there. A person's driver's license to their name. Okay, that I am going to say yes, because everyone has a different driver's license number. So if I give you a name, you will have a different driver's license number than the next person. How about jersey numbers to NFL athletes? Well, okay, multiple athletes do have the same jersey number, just on different teams. So technically speaking, we're going to run into issues there. The next one I'm going to talk about is the vertical line test. And once again, I'm truly hoping that this is a very simple concept. It basically says that if a vertical line passes through more than one point on the graph, at any point on the graph, then the function or the relation will not be a function. And no, I'm not going to ask you to discuss it, but what I am going to do is I'm going to emphasize this graph here. I could draw a line in multiple locations, and I'd say, ooh, there, I'm only hitting in one spot. But pretty much every place else that I draw it, I'm hitting in 2 spots. Since my vertical line passes through the graph at more than one point, that means that at some x value, we'll say this x value down here, I am going to have 2 different y values that apply to that x value, which is bad. So we're going to say, no, this is not going to be a function. Okay, and normally I would ask you guys just to analyze this and say, hey, is this a function? And I would ask you to stop, pause, think about it, and I would say, can I draw a vertical line that hits more than one point? And I'd say, yes, I can here, so no, that's not a function. However, in each of these little balls, I can say, well, I'm only hitting one ball at a time, so therefore, yes, that is a function. How about this wavy line here? Well, once again, I can pass multiple vertical lines across it, and I'm only ever hitting one ball at or one spot at a time. So I'm going to say yes, it is a function. Now, to those of you that have kind of been bored with what I've been doing so far, now's the point at which I am going to say you probably want to start paying attention again, because we now have function notation. Now, a function rule is an equation that represents some sort of output in terms of an input value. This is just a way that people describe things mathematically. So what I'm going to say is we write things in function notation. Now, all three of these are talking about the same function, 3x plus 2. Now you will notice that in the first case, we're talking about, well, my output is what I get out after I've plugged in for some input value there. Now the problem is that this sort of language is not convenient as we go higher in math. We don't always want to have a y. We sometimes want to write it in terms of, well, this is called f of x here, and we read it as f of x. I am never going to say function f of x. I want you guys to read this as just being f of x. Now, these two expressions mean the exact same thing. F of x means the same thing as y, so you don't need to worry about changing its value. However, you do need to understand that these two things are identical. And what can happen in this situation here is you'll be given something that looks like this, and you're going to be asked to evaluate the function. Well, when you're asked to evaluate the function, or to do what is finding f of 1, all you need to do is every place that there's an x in the original function, I just plug in that value there. Just keep it simple. Please, just keep it simple. This is one of these things that people struggle with. As long as it's numbers, it's pretty easy, but once we get into variables, people tend to struggle a little bit more. Once again, I need to emphasize that sometimes we're going to talk about it being an independent variable is the x. That's what you plug in. And the dependent variable f of x represents the output of the function. Okay, now if you're one of those people and you need to take a break every so often when I'm doing one of these longer lectures, I would say now's a good time to do it. Okay, because when you come back, we are going to be getting rolling on applying this to actual problems. So I'm going to give you a sense, pause, go get a drink of water, and here we go. Now, here is my function. F of x equals -3 times x squared plus 1. And what is the output for the given input? So I am now looking at f of -3. So what's going to happen on this is I'm going to say, all right, well, my function was f of -3. So I just recopy the original function, -3. I'm going to have something squared plus 1. I have not changed what's going on there because remember, this x just means I'm going to plug something in there. So don't make this difficult. And because of the way it's written, it's saying, hey, x goes here, so therefore x has to go here. Here it's -3, so therefore I sub it into that spot. So I'm now looking at -3 times -3 squared plus 1. Now, at this point, many of you are going to start just multiplying it out, and you'll be incorrect. You're either going to be talking about PEMDAS or GMA. They pretty much mean the same thing. You do anything in parentheses first, then you deal with an exponent next. And I do have an exponent here. That's that there. So I'm going to say it's going to be -3 to the second. I have to evaluate that. So I'm going to say, all right, I've got -3. And -3 to the second is 9. plus 1. And so here we go. We're now looking at negative 3 times 9 is going to give me a negative 27. And then I just add 1 to that to get an answer of a negative 26. Again, replay that if you need to. I'm hoping that goes well. Next. All right, I'm going to warn you right now, this is the one that it generally takes people a couple of attempts to get. Once again, I'm just going to recopy the function, except in the place of x, I'm just going to have open parentheses because it seems to help people to understand this better. I've not changed the value. This and this are exactly the same. That's what a variable is it's literally a spot that I'm going to fill stuff in. I just don't know what it looks like yet. All right, and now it's time for me to figure out what I need to substitute in. Well, in the place of the f of, they've got x plus 2. So what do I need to do there? Well, what I need to do is I need to substitute that whole x plus 2 into this function. Okay? Keep in mind, that's the trick. You've got to plug in 4x. Anything that is inside the parenthesis is going to be subbed into x in the original function. Okay? All right, and the next thing I'm going to do is I'm going to a bunch of people goof this up, even though they did this right, because algebra was not their favorite topic. And so what I'm going to do is I'm going to say, well, again, it's the whole GMA or PEMDAS thing. I have to do the exponential. The problem is I'm going to have a bunch of people say that x plus 2 quantity squared is just going to be x squared plus 4. And, you know, I'm probably going to cry and weep open copious tears. That does not work. Never, 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 never. Remember what it means to square something. To square something, you're multiplying it by itself. So what I'm really looking at on this is x plus 2 times x plus 2. And I'm going to emphasize, please be careful. Use the FOIL technique or use the double distributive. I don't care which way your teacher called it. So I'm going to have x times x is x squared plus 2x plus 2x plus 2 times 2, which is 4, which is now going to get me x squared plus 4x plus 4. And that's all good. So now I'm going to go back to my original expression here, which is going to be negative 3 times, we've got this x squared plus 4x plus 4 plus 1. And now I'm going to see what I can do about simplifying this a little bit. Let me distribute. I'm saying it's negative 3 times x squared is negative 3x squared. Negative 3 times 4x is going to give me a negative 12x. And negative 3 times positive 4 is going to get me a negative 12 plus 1, which gets me to a final answer when I just simplify this to being negative 3x squared minus 12x minus 11. Now, this particular substitution here is going to be really critical for you to have a function when you have to substitute another function in. Again, that sounds incredibly complicated, but once again, as you go higher up in various disciplines, not necessarily just math, business, a lot of times, your original piece of information that you're substituting in has to go into one function, and that function's value has to go into another. You just find out what the value is going to be getting so you don't have to do it in 2 steps. So I'm lastly going to show you one more example, and don't worry, it's nothing earth-shattering. We're going to do the same thing, but I'm going to be very careful on this. I'm going to say, once again, my f of stuff is here. So I'm going to say negative 3 times space squared plus 1, because that is that function up there. All right, and now all I need to do is substitute in I've got a 3 sitting out front. So I'm going to multiply 3 times whatever this ends up getting me. And remember that 2x there? Well, guess what? That's what has to go in the parentheses. All right, so now we are looking at 3 times -3, and I'm looking at 2x squared, which fortunately is not difficult to do. 2 squared does get me 4, and x squared does get me squared. Again, it's okay because I'm taking 2x times 2x. You don't have plus or minus like I've got here, which is why we ended up having to use the FOIL. Now we just multiply together my like terms and it comes out easily. And then let's just clean this thing up a bit. So I now have, again, I'm going to leave the 3 outside. I've got -3 times 4, which is a -12x squared, and plus 1. And finally, I'm going to distribute to give me a -36x squared minus 3. Okay, so once again, I've gotten myself someplace. Not terribly exciting, but still is going to get me towards an answer, and that's good. Okay, let's move on to, we're going to do the last little example, which has to do with coming up with some functions and given something there. Again, nothing terribly exciting. Let's just go on. I'll do 2 of these real quickly. Writing and evaluating a function. We're going to model a real-world situation using a function rule. Okay, so here we go. I've got tickets to a concert. They're available online for 35 bucks plus a handling fee of $2.50. The total cost is a function of the number of tickets bought. What is the function rule that models the cost of concert tickets, and then evaluate the function? So because it's concert tickets and I like to use variables that are descriptive, I'm going to say C for concert tickets, and I'm going to say C of T because it's in terms of the number of concert tickets. I'm going to say it's 35 bucks for each concert ticket plus a handling fee for each group of tickets. Okay, so let me clean that up because I have awful handwriting and I want people to be able to see. There you go. So there's my function. And now you're being asked to evaluate the function for 4 tickets. So I'm going to say C of 4 equals 35 times 4 plus 250. Okay, and 35 times 4 is going to get me $140 plus 250. So I'm going to say $142.50. Okay, and I'm going to skip that one, and I'm just going to go to this one. It says you're considering renting a car from 2 different companies. We've got Proxy Car Rental and Your Pal Rental. Well, let's see what we've got. It says Proxy Car Rental is going to be charging 32 cents per mile and an $18 surcharge. And Your Pal charges 36 cents per mile, but only a $12 surcharge. Okay, so we've got that situation going on. Let's come up with my 2 functions. Let's find the function that finds the cost of renting from Proxy. So I'm going to say, let's rewrite it in terms of, again, Proxy. I'm going to use P. And I'm going to say, how many miles have I got? So I'm going to say P of M. 32 cents per mile, so 32 cents times the number of miles, plus my $18 surcharge. That's a nice written way of describing the cost of renting the car from Proxy. Let's move down, and we're going to say, looking for a function that shows the cost of renting a car from Your Pal. Okay, let's do it here. We're going to say Your Pal, so I'm going to say Y of M. And let's go back up to the cost. It says 36 cents per mile, so 36 times mile plus a $12 surcharge. Okay, Cool on that. So I've now got my two functions. And lastly, it says which company is going to give you a better deal if you're going to be driving 820 miles. So I'll say proxy for 120 miles. I'm sorry, 820 miles, not 120 miles, is going to be just 0.32 m plus 18, except I'm going to drop that m and I'm going to immediately fill in that with the value they give me, which is 820. And I add those two things together with my calculator, and I get a cost of $280.40. And then I'm going to be looking at the same trip using Your Pal rental company. So 0.36 times 820 and $12, and that's going to be 307.20. So guess what? I am going to go with the proxy rental company. All right, ladies and gentlemen, I'm going to call it quits there. I'm going to let you guys work on the Math Excel, and hopefully things go well. Have a lovely evening, or afternoon, or morning. Take care.